Alright class, in this video we're going to start looking at the metric system. Now, we just got done looking at the US measurement system, and now so let's look at the metric system, which is our other system of measurement. There's three different types of measurements in the metric system. First one deals with length, the second one is capacity, and the third one is weight. And so if you remember from the last US measurement section, there was a unit fractions, okay? And so what I posted here were just pictures of each unit fraction that deals with length, capacity, and weight. And so if this is what you could use to convert between the different types of metric measurements. And so the metric system is one that most of us probably aren't very familiar with. We kind of use the U.S. system. That's the one we're familiar with. But just to kind of give you some examples of where you may have heard some different types of measurement or heard things about the metric system. If you run, like if you're a runner, if you do like 5Ks, 10Ks, 3Ks, or even longer distances, those are measured in the metric system. So for an example, a kilometer or a kilometer, however you pronounce it, is about 6/10 of a mile. So if you run a 5K, you're running about 3.1 miles, and so that's one area where length is used in the metric system. And with capacity is one where again, you may not be familiar with it, but when you go to a grocery store, if you buy like say 2-liter bottles or 1-liter Coke bottles, that's all measurement. Or if you buy a liter of milk, that's all the metric system. I know a lot of us buy 2-liter bottles of soda, and so that's using the metric system. And then the last one is weight. Weight is one that we really don't use very much. It's used a lot in medicines and nursing and sports. But just to kind of give you an example of grams and kind of their weight, if you have a nickel weighs about 5 grams. If you have a dollar bill weighs about 1 gram. So you can see that grams, which is the unit of weight in the metric system, it's not very heavy. Okay, but again, that's just a quick example of how the different measurements in the metric system work, or just examples of what they are. And so what we're going to do, just like with the U.S. system, we're just going to practice converting between different measurements within the metric system. So let's go ahead and get started on that. Alright, so here we have two examples. The first one is ask us to convert 7 kilometers to meters. And again, we're going to do use the same method we used in converting the U.S. measurement system. So we're just going to start with what's given to me. So the 7 kilometers. Again, if you want to make it a fraction, which I recommend doing. And now we're going to multiply that by the relationship between kilometers to meters. And so let's go back to the first page, and we notice that 1 kilometer is equal to 1,000 meters. And so we'll use that fact. And so remember, kilometers have to go on bottom, so we got 1,000 meters is 1 kilometer. I'm using abbreviations now. Okay, so now my kilometers, they cancel. And so we just left with 7 times 1,000, which is just 7,000. And so we get 7,000 meters for the first example. Okay, so again, we exact same process as in converting within the U.S. measurement system. So let's look at the second. We want to convert 60 milliliters to liters. So again, I'm going to start with what's given to me. So 60 milliliters over 1. Now we're going to multiply that by my relationship between millimeters, and milliliters and liters. And so if we go back to the first page, we see that 1 liter is equal to 1,000 milliliters. So we're going to go back, and we got 1 liter is equal to 1,000 milliliters. Alright, and so now what we have is my milliliters, they will cancel out, and so we're left with 60 over 1,000 liters. And then if we divide that out, we wind up getting 0.06 liters. And so 0.06 or 600 liters is equal to 60 milliliters. Okay, so again, we use the exact same process. Okay, all right. One thing I've failed to mention in the beginning is that the metric system, okay, is based off of power of 10. And so if you look at my two answers here, you notice that they're just, from where we started to where we finished, was just based off of a power of 10. Either we multiplied by a power of 10 or we wound up dividing by a power of 10. And so using that fact is what makes the metric system so good. And so there's another way that we can convert between the metric system, an easier way. And so what I want us to do is let's take a look at that method now. All right, so here's our alternative method is just using the metric conversion line. So here we have a metric conversion line. This one is in terms of length right now set for meters, but meters, length, capacity, and weight, they all work the same way. And so if we notice here with our instructions, step one, you want to find the unit you're given on the metric line, and then you want to count the number of places to get to the unit you're going to, and then just move the decimal in your answer that same amount of places and in the same direction you did. So this right here, using the metric conversion line, is going to save you a lot of time, and it's going to be a lot easier, I think, than using unit fractions. But let's just look at some examples and see how this works. Alright, so here we're asked to convert 2.5 meters to millimeters. And so the way the alternative method works is you figure out where you're starting from. So we're starting from the basic unit, we're starting from meters, and we need to wind up over here at millimeters, okay? So that's your first step, is find out where you're starting at, find out where you're finishing at. And now we just see how we move there. So to get to there, we go 1, 2, 3 places to the right. And so when we take where we start from, we just take our decimal and we go 1, 2, 3 places to the right. Again, fill in zeros for placeholders. And so what we get is that 2.5 meters is equal to 2,500 millimeters. And so all we're doing is just moving the decimal, either to the right or to the left. Alright, so now try a few on your own. Alright, so here's the 3 problems I would like for you to try. Alright, so let's look at these 3 problems now. So the first one, we wanted to convert 80 milliliters to liters. So if you remember, if you go back, so I'm just going to go back to the previous one we used, and if we look, we're going from milliliters to liters, and so we're down here at milliliters, and we're just going to the basic unit. Again, now these would be liters and milliliters, but we're starting down here at the milliliters. We're going to liters, so we have to go 1, 2, 3 places to the left now. So we just take our decimal, and again, if you don't see a decimal, we understand it to be at the end of the problem. So we're going to take that decimal, and we're going to go 1, 2, 3 places to the left, and so what we wind up getting is just 0.080. You can leave it off, but we get 0.08 liters. Alright, very good. Looking at the next one now, we want 13.72 kilograms to grams. So again, I'm going to go back over here, and we're starting at kilograms this time. Okay, so this would be kg now, and this right here would just be g, but we're going to grams. Okay, so to get there, we got to move 1, 2, 3 places to the right. So let's go back to our problem now, and we're going to go 1, 2, 3 places to the right. We must plug in a 0 for a placeholder, but we get 13,720 grams. Alright, very good. And then the last one, we're going from centimeters to meters. So we don't have to change the units on this one. We're just going from centimeters here to meters. Okay, so we just have to go 1, 2 to the left. Alright, so 1, 2 to the left. So 1, 2. And so we get, you don't have to put a 0 in front. It's totally up to you, but you get 0.927. And now we're in terms of meters. Alright, so hopefully you found this pretty easy. But that's all there is to converting between the metric system. You just, because it's based off of power 10, we learned in the decimal chapter, when you divide or multiply by power 10, you really are just moving the decimal either left or right. And so that's all we have to do in this one. And so again, you want to learn the you want to learn this this conversion line. Okay, so you want to learn this conversion line and learn the order of the prefixes, because that's what determines which way we move and how many places we move. So again, if you have questions on that, just let me know, okay, and we can look at it. But now what we're going to look at is we're actually going to look at problem solving. So we're going to go back to word problems that deal with the metric system. All right. So in this problem, it says Kim has 5.9 meters of ribbon. How many centimeters of ribbon can she use to tie 9 packages? Round your answer to the nearest tenth of a centimeter. So she has a total of 5.9 meters of ribbon. She needs to use that to tie her 9 packages. So we're trying to figure out how much of ribbon in terms of centimeters can she use for each package, each one of the 9 packages. So the first thing we got to do is we got to take the amount of ribbon we have and we got to convert that to centimeters. So 5.9 meters. Okay, so now if you remember your chart, you're going to the right, and we're going 2 places. So we're going 2 places to the right. So 1, 2. And so we get 590 centimeters. So 5.9 meters is equal to 590 centimeters. And so now we're just trying to figure out how much she can use per package. So we just take the 590 and we divide that by 9. And when you do that and you round to the nearest tenth, you wind up getting 65.6 centimeters per package. So again, just like the problem solving with the U.S. measurements, you just have to take what's given to you, convert it to the measurement that you want to finish with in your problem, and then just make sure you always answer the problem in context of the word problem itself. So there's plenty more examples in your book. I'll post some more examples on Edmodo. We'll go over some of these in class as well. So just make sure you're getting plenty of practice on the problem solving with not only the metric system but also with the U.S. system that we looked at.